If you are building a drone, robot, or a balancing board, then the IMU is the heart of your project. So in this series, we will interface the IMU with that STM32 Black Pill, and by the end of this video, you will be able to successfully communicate with the IMU sensor over SPI and read the WhoAmI register. Okay, now we will read WhoAmI register value from the IMU. So for that, I have already added a breakpoint at while loop here. Now let me run in debug mode. So the debugger is waiting for the connection. Now we can see that connection is successful. Let me switch it here. Then let's click on resume. We can now here, if we are reading this variable value, it is displaying at 0 as PA, which is correct. We encountered a small issue during initialization. As of now, we have added a workaround. We will fix that later. Before interfacing ICM-20948, let's understand what is ICM-20948 is. The ICM-20948 is an inertial measurement unit commonly referred as IMU. It has 3 sensors on a single chip, like 3-axis accelerometer, 3-axis gyroscope, and 3-axis magnetometer. It is widely used in applications where accurate measurement of orientation and motion is needed. So why SPI instead of I2C? SPI is a full duplex, I2C is half duplex. SPI is faster and I2C is slower. SPI uses 4 pins, I2C uses only 2 pins. SPI is good for drones. I2C is good for super sensors. Flight controllers like Betaflight and RD Pilot also use SPI-based IMUs because it is faster and provides low latency. Now let's understand the module pins. So VCC will be connected to 3.3 volt. Ground pin will be connected to the ground. SCK will go to SPI clock. SDI is master out, slave in. SDO is master in, slave out. CS is chip select, and INT is interrupt. Now let's connect Black Pill to the IMU. So Black Pill PA5 will be connected to the serial clock. PA6 will be connected to the SD out. PA7 will be connected to SDI, and PA4 will act as a CS, chip select. Then VCC will be connected to the Black Pill 3.3 volt, and here ground will be connected to the ground. So here PA4 we have configured as a GPIO, and we are selecting the software controllable method of chip select. So in this section we will generate the code and we will show you a demo where we will read that WhoAmI register value and blink the on LED if the communication is successful. So first of all, you need to open the CubeMX IDE. Then click on Start My Project from MCU. Then here in the commercial part number, search for STM32F411C EU. Click on this part number, then it will automatically open the new project. Click on connectivity, click on SPI1, let the node be the full duplex master node, hardware NFS signal be disabled. Let other settings be at their default only change the prescaler to 64. I didn't try it with the prescaler 2, I only tried with that prescaler 64, that is why I am using the 64. And at the clock polarity and the clock phase at default only, that is low and 1H. NFS signal type is software. Then for the chip select, we are going to use the GPIO4. Let's make that GPIO4 as output. Make it output. Similarly, we will be using onboard LED just to show that it's communicating with that IMU and the communication is successful. So we will make it as output. So we have configured the GPIO13 as output. Then click on generate code. Click on OK. Here type STM32 Black Pill. And new interface. Change the tool chain to STM32 Cube IDE. Click on generate code. It should take only 1 minute to generate the code. Now the code has been generated. Now click on open project. Click on launch. The project has been imported successfully. Now right click on the project and then click on build project. So if everything is correct, then it should get compiled successfully. Yeah, the code has been compiled successfully. Then open the code source main.c. You can see that it has added some GPI initialization code and the SPI initialization code and the while. But as we want to communicate with the IMU, so we will be needing the 102 function just to read the IMU register value. So I will just copy paste the code which I have written. So let paste it at top only, and this yeah. So this part will go inside the main function. So basically, we are just calling this function, just bus in it, and then reading the register value. And if the register value is correct, then blinking the onboard LED. Now let me compile the code, build project. Okay, here is some error. Let's go here where it is defined. So I will put it at top. Then build project. So now we can see that compilation is successful. Then click on debug. I have already connected STM and the Black Pill board. So waiting for debugger connection. So here the connection is successful. Click on switch. Click on resume. So here I can see that my onboard LED has started blinking. So I will confirm whether our correct port part is hitting or not by just putting a breakpoint here. Right click here and then add a breakpoint. Apply breakpoint. You can see that it is hitting here, and now my register value is 0xEA. So that means we are able to communicate successfully, and our onboard LED is also blinking. Yeah, thank you.